Hey guys, welcome to the channel. This is BioBudge, and today we're going to be going over the basic usage of IQtree3 in the command line. Now, IQtree3 is a phylogenetic reconstruction software that takes a multi-sequence alignment and is able to produce a phylogeny that we're able to use in our research. Now, this tutorial assumes that you have a working understanding of the command line and of phylogenetics, and also that you have IQtree3 installed. If you don't have any of those things, I'll be leaving resources in the description below to check out. But before we get into the command line, let's talk about the file that IQtree3 needs. Multi-sequence alignment is basically a file that contains homologous sequences from across different organisms that have been aligned using different software tools such as MAFT or Clustal. If your sequences are unaligned, you can find resources to do that in the description below as well. And also that file needs to be in a specific format. The formats that IQtree3 accepts are FASTA, Nexus, or Phylup. Now, if you have all those things, let's dive into the command line. All right, so here we are in the command line. In my current directory, I only have one file, which is the example Phylup file, which is used in the official IQtree3 tutorial. And the first option we're going to talk about is the -s option. This option is what points IQtree3 to the file we want it to. And running IQtree3 means calling the program, -s, pointing it to a file, which in this case is our example Phylup, and we can just hit enter. IQtree3 defaults to using its model finder, which as you can see is testing a bunch of different models, and then uses the best fit model to do the maximum likelihood inference, and then produce a tree. Now, the files that we are most interested in that IQtree3 generates are the IQtree file, which is a human readable summary of the analysis, and then also the tree file, which is the phylogenetic tree that it produced in Newick format that we can feed into other programs such as FigTree. Now, if we open up that IQtree file, we can see that it has very nice summaries of the different models it tested with all of their different values. We can also see a ASCII rendering of the phylogenetic tree produced, unrooted, which is super nice. But let's say that we change our multi-sequence alignment, something happens, we want to redo the analysis. If we just try to run that command again, it won't work. It doesn't want to overwrite the files that it has there. So we have to use the redo option, which we can just tack on to the end of our command, which will redo the analysis, rerun everything. Do keep in mind that this will overwrite the files that are there, so be careful when you do use it to make sure you're not overwriting anything that you'd like to keep. All right, the next option that I want to talk about is the -bb option, which does ultra-fast bootstrap approximation. This gives your tree bootstrap values, which are a measurement of how robust those nodes are, like how confident we are that those are that the data reflects that those are where the branches are. And so you can do that by doing -bb and how many replicants you want to do. And the minimum in IQtree is 1,000. So we can enter and it'll do the exact same thing. It's going to test all these models. And then it is going to do the bootstrap replicants. And then give us our final results once again written. We can see that the ultra-fast bootstrap approximations are written to these files here. Now this data set is super small, so it runs really, really fast. But when we're working with larger, more realistic data sets, we're going to want more computation power and leverage the cores that our computer has. And we can do that with the -nt option. This allows IQtree3 to use more of your cores. So right now, by default, it uses 1, but if we do -nt2, we can get it to run faster. If you don't know how many cores your computer has, or you don't know how many to assign to a given job for IQtree3, you can use auto, which will automatically test the number of cores that your computer uses. The final flag I'd like to talk about is the -m flag. Now, what that does is that IQtree3 by default uses its model finder and it tests a bunch of different models and uses the best one that it finds, which while convenient can often be computationally expensive. It takes a while. And if we know the model that we already want to use, we can just use the -m flag, which skips that expensive computational step. So you can use -M, put in the model you wish to use. In this case, we'll just use the GTR model. And you know what? Let's just use it 2 cores this time instead of the 1. We can see that it will blitz through it pretty quickly, and we're already done. Thank you guys so much for watching the video. I hope it was able to kickstart your journey using IQtree3 in the command line. If you have any questions, be sure to leave them in the comments below. And if you enjoyed, be sure to like and subscribe, as I will be doing more bioinformatics tutorials in the future. Have a great rest of your day.